Hi folks, we're going to take a look at the solution for page 106, number 19. So they want us to find the derivative of this function here. So there's a couple of ways we can go about doing this, but first thing to notice here is that we've got this quotient. So we're definitely going to start off with the quotient rule. And in taking the quotient rule, well, we're going to have to take the derivative of the numerator. And this is where we've got a choice to make, because we can either use the product rule now to find the derivative of the numerator, which is two easy functions, okay, and then of course to take the derivative of the denominator you'd have to use the chain rule, okay. But of course the other option we have in the numerator is to multiply this out and then have just one easy polynomial to take the derivative of. So I think that that's the best way to go. So first thing I'm going to do is multiply out the numerator. So I've got x squared minus x to the fifth, and then all over 1 plus x cubed. Okay, so I'm dealing with a simpler numerator to differentiate. Okay, so now it's all about being very careful in our stepwise process. So in order to find the derivative, apply the quotient rule. So first I take the derivative of the numerator, and that's a pretty easy derivative. So it's just 2x, which is the derivative of x squared, minus derivative of x to the fifth is 5x to the fourth. Okay, and then I multiply that by the denominator function, 1 plus x cubed. Okay, then I subtract, and now I do the opposite. I take my function, the numerator, don't change it, x squared minus x to the fifth, times the derivative of the denominator. Okay, so now here we need to use the chain rule. So here I can make 1 plus x my intermediate variable u. So first I'm going to take the derivative of u cubed, which is 3u squared. So 3 times u, which is 1 plus x, all squared. Okay, and now I have to take the derivative of u with respect to x. So derivative of 1 is 0, and the derivative of x is just equal to 1. So the derivative of u is just equal to 1. Okay, and then all that over the denominator squared. So this is 1 plus x cubed, and I'm squaring that, so that's going to be 1 plus x to the sixth. Okay, so here's my unsimplified version, but let's go ahead and simplify this. And I want you to recall a neat trick we saw when we're dealing with these types of functions, and that's to look for a common factor in our numerator before we start expanding or doing anything like that. And here I notice that I've got powers of 1 plus x that are common to both of these two terms. Okay, and they each have 1 plus x squared as a common factor. Okay, so the first thing I'm going to do is I'm going to remove the common factor of 1 plus x squared. Okay, and then look for any other common factors. Okay, now you might not notice it right off the bat. I sort of see it here that this has a common factor of x, that has a common factor of x. So if you think of it, you can factor that out right away, but I'll just leave it and we'll see that it'll come out later on. Okay, so let's see what's left now in this numerator. So now I have my 2x minus 5x to the fourth. Okay, and here I just have one factor of 1 plus x left. Okay, 1 plus x. Okay, now here I've got my 3. Okay, 1 plus x squared has been factored out, so the only thing else that I'm left with is the x squared minus x to the fifth. Okay, and then all that over 1 plus x to the sixth. Okay, so now what I've done is I've managed to really simplify the algebra that I have to do to simplify in the numerator. Okay, so first I notice that I've got factors of 1 plus x in the numerator and denominator, so that cancels out with 2 of these in the denominator, so I'm just left with 1 plus x to the fourth. Okay, and now let me work at simplifying the top. So here just got to make sure we're careful with our algebra. So here we've got 2x times 1, so 2x times x is 2x squared. Then we've got negative 5x to the fourth times 1, so minus 5x to the fourth, and negative 5x to the fourth times x, so minus 5x to the fifth. Okay, and here we've got minus 3x squared plus 3x to the fifth when I expand that expression. Okay, and all of that over 1 plus x to the fourth. Okay, so you see a lot of this here is just about being really careful with our algebra. So here let's start with the highest powers. So we got negative 5x to the fifth plus 3x to the fifth, so that's negative 2x to the fifth. We see we have powers of 4, so minus 5x to the 4. No cubic terms, but here we've got 2x squared minus 3x squared, so that's minus x squared. And lastly, I'm just left with the plus 2x for 1 plus x to the fourth. Okay, and I suppose we can clean this up a little here. So I've got a common factor of x, but since my leading term is negative, it's always nice to have a positive leading term. So I'm actually going to factor out a negative x. Okay, so what I'm left with in the numerator is 2x to the fourth. Okay, this is going to become plus 5x cubed. Okay, this is going to become plus x and minus 2 all over a 1 plus x to the fourth. Okay, and that's about as far as I would expect you to go. Factoring something like this, if it even is factorable, is not too easy. So there you have it. I would like to mention that it looks like the answer in the back of the book is incorrect. I took their factored form, multiplied it out, and did not get this expression here. And just to be sure, I checked an online derivative calculator, and this is indeed the correct answer. Okay, so just to recap here, okay, first thing is to recognize that you have to use the quotient rule, okay, and then if you think of it, to multiply out the numerator so that you have an easier function to differentiate when you're taking the derivative of the numerator. Otherwise, had you left it in this form, you would have had to then use the product rule when finding the derivative of the numerator as part of the quotient.